Hello everyone. Okay, so as you know, these past couple of weeks we've been going through this Python course, and today is going to be the conclusion of this course. Um, this is going to be the last kind of lesson in this course before we move on to kind of like the second section, I guess. And so the second section is going to be on CodingBat, and you can sign up for that. Um, I believe on their website, capitalroboticsclub.com. You should also receive an email about it. But make sure that if you want to continue learning about Python, sign up for that course. So all the details on that course will be listed on the website and stuff. So with that being said, I guess let's get into the topic for today. So today we're going to be talking about classes and objects. And classes and objects is going to be the first, not the first kind of, but it's going to be an interesting concept in that Python is unique when relating to classes and objects, and we'll kind of see that later on in this presentation. But this belongs to the OOP, Object-Oriented Programming. So remember that acronym. It's going to be very important, and you're going to bump into that later on if you're going to learn about other different programming languages. And so classes and objects is essentially just code reuse, except on a much larger scale, I guess. And so we went into packages and modules last class, well, modules and packages. And so that is kind of like the very top. And you notice that we kind of skipped over the classes and objects. And I said we would get to it this class. And so now we're going to kind of explain why we skipped over this. So Python can be written as a procedure program, as procedure program is essentially just step-by-step instructions. So the basic instructions that we learned at the very beginning of this course, like writing down the if statements, the for loops. So essentially no functions, no classes, no modules, no packages, no nothing. So just bare code written inside a file, right? And that is kind of like the very basic level of Python that many beginners write. Now, this kind of programming, known as procedure programming, is very it can be written essentially the syntax can be written in Python like this. But in languages like Java, you cannot use procedure programming as the compiler simply won't allow it. Essentially, you need to write a class and object. So in procedure programming, everything that we've kind of learned out so far is basically procedure programming. And so it's essentially just step by step, the CPU just follows everything that you write. No matter that be a loop, defining a variable, printing out something, there's no like going back to a certain line and like calling a function or creating an object or something. And essentially, it's the most basic form of programming, I guess you could say. It's very simple, very straightforward, and very easy for even beginner programs to understand, because there's no confusion, I guess, in the order of it. As the programs get longer, more complicated, have more values, data, instructions, it becomes a lot more difficult to keep track of the code, even if it is quite straightforward in procedure programming. As although it may seem like, oh, well, it goes from line to line, and there's kind of nothing really blocking you from understanding it, as it seems like it's very straightforward, it gets complicated when you say have hundreds of variables. And that's why we learn things like data collections, like lists. However, sometimes we have to copy over this a single bit of code multiple times. and we learned about functions. Now, what happens if you have multiple functions that you need to write? Well, as you can see, there are many different scenarios in which procedure programming is not exactly the best or most efficient way to go, and that is where that's where object-oriented programming comes in. And oftentimes, it's difficult in order to kind of program something that is in the real world with procedure programming, as there are so many different things that you have to take account of, that in order for you to write it in procedure programming, you would need thousands of lines. Whereas in OOP, you would only need, say, 100, 200 lines. Now, this might be a tiny bit of an exaggeration, but essentially, object-oriented programming saves you a lot of time and effort. So you may be wondering, well, why do we have the picture of this game over here? Well, this game is Clash of Clans. I'm sure a lot of you have heard of it before, and this is going to be our example for how we're going to learn object-oriented programming. And the reason for this is because it's quite a typical example of it, as we'll show you later on in this presentation. And hopefully you guys will be able to relate to it a little more because, well, I'm sure many of you have played this game before. So computer games like Clash of Clans emulate like the real world characters, and with the characters, the buildings, the vehicles, basically a lot of things, and obviously slightly modified in order to make the game more exciting. So here we have kind of 6 different characters. So we got a barbarian, an archer, a giant, a wizard, and a witch, and a goblin, right? So all of these seem to be quite different characters, right? And once we go down and focus on each one of them, we can kind of see what exactly characteristics belong to each of them. So we look at, say, placing down a bunch of barbarians when attacking a village. And we can see that these barbarians are controlled by a computer algorithm, presumably something along the lines of AI. And they attack the village, and each barbarian character shares some attributes with some other characters, and also shares some actions with the other characters. So some of the attributes that are shared between these different characters are that A, the barbarians have to be placed somewhere, meaning that they all have an X and Y coordinate. B would be that each barbarian has a certain amount of life remaining. And C would be the level of the barbarian. Each barbarian has a certain level, right? So everything, all of these barbarians can also perform certain actions, such as like hacking and running. So as we can see, so these barbarians over here, they kind of share some qualities with each other. Although the details of the qualities, or the rather values of the qualities, may vary from one another, they have these kind of general outlines that they follow. So I'll let you look at this for a second and think about this. So in programming, we saw that there's 2 kind of things that the barbarians have. they have attributes, and they have actions, right? So attributes are kind of like values, right? So these values, although they can change, they are kind of storable. And we saw, well, if we have values that we want to store somewhere, all we need to do is get a variable, right? So essentially, each one of these attributes has a certain variable associated with it. And so everything from the placement, the life remaining, level, I'm sure there's many other attributes that you could um, find in a barbarian. All of these things are stored in variables. Now next is going to be actions, right? So actions are not are not attributes, as they allow the barbarian to perform something. Although each, say, level of barbarian may perform the action to a certain better or worse standard, each of these actions can kind of be stored in like a function. Now we learned that functions are essentially blocks of code that we write into a not data structure, sorry, a code structure known as a function, right? So we have the basic characteristics of the function with the define, all of the parameters that it needs, the function name, the semicolon, or rather the colon, and all of the code that you need within it. And we learned how to call the function as well. Now I'm going to use a word called methods. So all these actions are actually coded into methods. They are not functions. And the reason for this is because when looking at a method and a function by itself, they look exactly the same. And the reason is they are exactly the same, except for one thing. And that's where you have to take a bigger picture kind of look at it. When you take a bigger look at it, you can kind of see that these methods are actually located inside of a class. And a class will kind of show how it is written, but essentially the word method and function refer to kind of the same type of structure, I guess. Although they are located in different places, with the functions located outside of a class and the methods located inside of a class. And typically, these methods are used to kind of update the values stored in attribute variables. Whether these attribute variables are related to the barbarian itself, or say to a building it's attacking, a wall it's attacking, another troop it's attacking. So essentially, that is the point of these methods, right? So these methods are going to perform actions that each one of these barbarians is going to be capable of doing. So now that we see, alright, so these barbarians, it would be pretty nice if we could somehow store all of these attributes together. And how would we be able to kind of store and track all of these kind of attributes in an amount of space that's very easy to kind of locate? Well, we learned about data structures before, like say a list. And although technically that is plausible, we also want to keep all the functions with it as well. So that would make it rather impossible to form just a list. So instead, what would happen is we would keep all of these actions that any of these barbarians can perform together into a place known as a class, right? So I kind of been just referring to a class as some sort of like object that I've never really shown you the code. We will see that later in the presentation, but we can kind of see that this class is pretty powerful, right? It can store all of these attributes, all of these methods or functions in a single place that we can call over and over again as many times as we want. And the best part about this is, in order to create a new kind of instance of a class, or create a new version, I guess, all we gotta do is just write one simple line of code and store it in a variable. So I'll let you think about this for a little bit. And so obviously you can see that a class can be very helpful when your program starts introducing numerous variables, numerous attributes, or numerous methods. So, this is the code. Now, at first, it can seem a bit simple. There's not much really to it. So, we're going to kind of go over the basic template. So, as we can see, we have class Barbarian. This is defining the class. And well, the key word for this is going to be class. And the name is going to be Barbarian. That's all there is in defining the class. Now, inside of the class is where it gets a tad bit interesting. So, we see two different kind of methods here, right? We have define underscore underscore init underscore underscore. And we also have define hack. Now you're like, what in the world is this? What does init mean? Well, init is short for initialization. And essentially, this initializes this constructor. And so this constructor is going to be kind of like taking the parameters of your objects and assigning them to certain attributes, right? So over here, we can see that there's things like the class attributes. We have hair color is yellow. And we can see that no matter what level of the barbarian it is, the hair is always yellow, right? So that means that this hair color right here doesn't have to change for the entire, like every single instance of this class. So what this means is that it's kind of just hard-coded into the class. Whereas something like name is not hard-coded. And the reason for this is because it varies from barbarian to barbarian. And that means that when we create an object or an instance of this class, we have to say the name of the barbarian that we want to create, right? Otherwise, we won't know, oh, this barbarian, say, isn't named Bob or something like that. Or this barbarian should be named Joe, right? So each barbarian has a different name or identification tag, I guess. And you can see that you have something called self. And you're wondering, well, what is self? Well, essentially what self is that it refers to the object itself. And what this means is that when you call it, say, self.name, this means that it's referring to itself, its own object. And so it's defining, or rather initializing its name as whatever you put into it in the constructor or the parameter when you call the function. Call the constructor and create an object. And down here, we just have a regular method. It's just going to be defining hack self, and you just print self.name will do some damage. And we can see there's a lot of selfs going on, right? So that is, and when you call these kind of methods and create an object, or say you have the object do a certain action using a method, what needs to happen is you essentially just ignore the self. The self is kind of like a parameter that's not needed, I guess, because it knows that it's kind of referring to itself. So it's a keyword that you need to write inside the class, but you don't need to call when it's outside of the class and you're trying to call it as an object or something. So I'll let you guys look at this. This is quite important in many other languages. Obviously, it can be important in Python. And as a matter of fact, I suggest you do some practice with this. Although classes can get a tad bit confusing, so I would suggest staying on the simple side for a little bit and slowly working your way up to more complicated OOP. So obviously you want to get yourself familiar with this. Um, when writing the method, you're always going to make sure you want to have your attributes, your initialization constructor, and obviously all your methods. So we can see that the class barbarian collects all the common attributes for the characters, and between the as well as the common attributes, it also has all the common kind of actions that these barbarian characters can perform. And using this class barbarian as kind of a template for every single barbarian that we're going to create using this template, we can create as many barbarian objects as we want in our program. And each barbarian object is going to have their own set of attributes, and they can all perform the same set of actions. Alright, so this is going to be actually creating these objects. Now, the words class and objects come hand in hand. And the reason for that is because, well, objects are going to be instances of a class. So when you actually use this template that you just created and create something, that thing is called an object, right? So right here we can see barbarian A is equal to barbarian Tom. So we see we have the class name over here, and we have the one parameter that we need. And as we can see, all we need is name. So essentially we just created a barbarian named Tom. So all of this object over here, this is the object, by the way, is stored in barbarian A, the variable, right? So this variable, now that it has barbarian Tom stored in it, we can call any method inside of this class, and we can see we can either call for any instance attributes, say barbarian A.name, or we can call any methods like hack, right? So there's obviously many possibilities that you can do with this, and this is kind of very important. Once you write the class, it is very important you know how to make instances of a class or make objects. And you also need, it's very important for you to be able to kind of call on the attributes or the instance variables. Alright, so now we see, obviously we can call these kind of instance variable attributes, or instance variable, sorry, and we can call and kind of look at these attributes, but we can also look at the class variables or the common attributes like hair color. So no matter which barbarian you call on, it will always return yellow. And so finally is going to be calling the methods. So we can see back here we have one method called hack, and all three of the barbarians can hack. So Tom can hack, Jerry can hack, Spike can hack. So ignore these parts of the thumbnail for a second. So as we can see, we have lots of barbarians here, right? So you can create as many barbarians as you want. And obviously a game like Clash of Clans has servers that are perfectly capable of being able to kind of summon all these barbarians without any kind of computer problems. And they can be created, and they can also be deleted as the game needs. And each barbarian has its own set of attributes. Obviously, with troops that vary in more ways are going to have kind of more instance variables, and troops that have less variation are going to have more class variables. And each one of them, since each one is technically an individual kind of instance of this class, can be individually controlled. So just because everything comes from the same class doesn't mean that they're all controlled by kind of like one method or something like that. Each one has its own method that can be called. Now obviously you can write a program that will call the same action for every single one of them, but that is up to you. And so now that you have kind of like say 5,000 these individual barbarians, you can do whatever you want, and that's where kind of the computer's AI algorithm will kick in, and it will do whatever it needs to. So now that we've learned kind of how we can create a class for a barbarian, we can create a class for anything. An archer, a giant, a wizard, a witch, a goblin. You can create as many classes as you want, and you can create as many objects of the classes as you want. I mean, as long as you don't crash your computer, of course. The only limitation is going to be your computer. Now, typically, if you're just going to create a small project, your computer storage should never be a problem. And when you program each one of these classes, you can kind of see, okay, well, each one of these kind of troops, they have different characteristics. Like, I want my giant to be much bigger than the barbarian. Instead of, say, 5 pixels, I want to be 10 pixels. And so then you could set, say, the class variable as 10 pixels. And obviously each one is probably just going to have its own like level system, I guess. So that could be an instance variable. And this is going to be a little hard to understand at first, but there's things known as superclasses and subclasses. And so these kind of superclasses and subclasses, we can kind of guess what the meanings are based on the names, right? So superclasses is essentially going to be almost like a class of a class. It's kind of the similarities of all of these classes together. So what do all of these classes do? Well, they can all hack, I guess, or they can all do damage in some sort of way. Now, the way they do damage, how much damage they do, that's obviously going to vary from troop to troop. And that's why, again, something that you don't need to necessarily completely understand is going to be something known as overriding methods. Now, obviously, that is quite complicated. I do not expect you guys to understand this. For now, just stick to the basic classes, but just know that there are many different possibilities, many different ways you can manipulate your classes to do whatever you want. And now that we've seen, okay, well, we can do it to all these different troops, well, what's stopping us from doing it to every single building, every single wall, every tower? Essentially what I'm trying to say is that classes can be associated with anything. As long as you know the attributes that you want to code, the different instance class variables, all the functions or methods that you want to program into it, then anything can become a class. Right? So now that we've kind of seen, alright, well, if we want to create, say, 5,000 barbarians, all we need to do is just create this barbarian class and create 5,000 objects. That's a lot easier than making, like, copy and pasting, say, 5,000 of the same functions over and over again, and slightly editing them for each one of them in order to fit the certain needs of each one, right? So we can kind of see that, well, class as an object can be quite useful, right? And now is where we're going to finally tie back to the real world and how we are going to be able to capitalize off of classes. Now we've kind of seen how these games can capitalize off of them. Well, classes and objects can be associated with anything, and they allow you to package as many variables and functions slash methods as you want into kind of blocks of code that are used as templates in order to be manipulated, reused, and created instances of, right? So this kind of chart over here, graph, is a great way to kind of show how OOP works. So we have this class, or this car over here, right? So this car is going to be some sort of car that has some sort of, say, special engine, special design, special, say, wheels or something, or anything that could distinguish it from other cars, right? We then have a constructor. So this constructor, or this factory, right? So this factory can construct the car object. And obviously, inside a factory, you can have different paints of a car. You can have red car, you can have black car, you can have blue, yellow, green car, any color you want, essentially. And you can create as many as you want, as long as you have the time and the resources, right? And so this will kind of bring us back to the computer hardware and kind of the limits of your computer, right? So you can kind of create as many objects as you want from a class, and with practically no limitations. So I'll let you think about this for a little. Alright. So now that we've kind of talked about the procedural programming in the very beginning, and we talk about how all of that is just kind of straightforward programming, now the use of classes is actually an entirely new type of program known as object-oriented programming, or OOP, right? So not all computer language actually support OOP. Like C does not support OOP out of the box. Obviously, you can code it in, but there's no really point in doing that if you're going to be using C, because C has its own special features that you want to use and stuff. Now, Python is unique in that it supports both procedural and object-oriented. And this is why it is considered the best for people who are trying to learn programming for the first time, as it allows the most options, is the most flexible, and is oftentimes the easiest for beginner programs to understand and follow. Java is a full OOP language. Why make it full OOP? Well, Java is typically tailored towards more professional backgrounds, such as companies. And the reason why you want a language to be full OOP is that you want kind of a standard. A standard in that you want every single program to follow some sort of pattern, right? So the pattern in this case for Java is going to be creating classes for everything. And as we saw before, classes make everything organized, everything super easy to use and access. And of course, this isn't the case with procedural programming all the time, as things can get quite messy. And so that's why Java is known as kind of this more professional programming language, if I may say. And finally, this brings us to the closing thoughts of this course. So, in this course, we've kind of covered two main sections. We've gone through the computer hardware, and we've gone through the software, right? So, kind of look at this chart for yourself for a second, and I'll kind of explain it as you look through it. So, we started with the CPU architecture, all of the hardware in it, all the computer pieces, all the special things about the computer, and we learned about how There's the hard drive with all the data stored in it and how the RAM fetches the information from the hard drive. And once it gets into the RAM, then the CPU then fetches all the data, all the instructions from the RAM, and it can run it. And we learned that the CPU can perform two types of calculations: full adders and Boolean logic gates, or in other words, arithmetic and logic. And so from this kind of knowledge, we learned that all these programming languages essentially just manipulate these two calculations over and over again in a way that it's easy for us to understand and us to use, right? And from that, we kind of learned the basic variables, the basic data types, and then we learned how the operators worked. And after the operators, we inside operators rather, we learned about how there's arithmetic operations, there's logical operations, and inside logic operations, there's iterations, there's decision making. Decision making meaning like if statements, iterations meaning for and while. And we moved into input and output and functions, and finally OOP. And obviously this is a lot to take in a short course of only a couple of weeks, and we covered a lot of information, and this is actually going to be kind of the main stretch, one of the harder stretches in learning programming. But in order for you to kind of learn programming to the best of your ability and kind of be able to use it later on, we highly suggest that you do a lot of practice. And we kind of brought up this website a little before. It's called CodingBat, right? So we asked that you did some of the questions inside of CodingBat, right? And inside of all these questions, they will test the basics that we kind of learned in the course. Pretty much everything up until functions is covered inside this CodingBat course. And in the next couple of weeks, we will be able to host a CodingBat course in which we go over these questions, and we can kind of help you guys for any questions you may have, and kind of make sure that you guys fully understand all of these questions that go inside here. So if you haven't already and you're interested in this, go and sign up. And I guess that kind of wraps up our course. So if anyone has any questions, go ahead and ask them in chat right now. And if not, thank you for watching, and we hope to see you guys in the next course. Alright, it looks like we are done for today. Thank you everyone for watching, and I guess hope to see you next course.